All right. I think it's time.
Yeah,
So-
and I've got a glass and I've got a bottle. I mean, this part has already started. So, fantastic. Well, for those of you who were a little bit ahead of time, you noticed that we did a live hotfix in production by doing the last patch, which was to push correcting the title so that it actually correspond with what's in the schedule for the conference. The content, however, is the same. So rest assured.
Rest assured, yes. All right, so fun to see that many of you would like to learn what we have to talk about when it comes to Log4Shell exploit. As it turns out, that was like a tsunami in the Java community, which didn't affect you, of course. Right?
So everyone here remembers like December last year about the
Yeah.
And you all got some call from a CIO or CTO saying, you have to fix this. And you were going, duh.
Yeah. Anyhow, who are we? Let's talk. Oh, we're standing on the right side now. That's pretty good. Yeah. My name is Daniel Deogun. I'm a developer at heart. Dan wrote this. I'm a coder and quality defender. And basically what it is, I really love building great software with high quality standards. Dan, who are you?
Yeah, so I had to take the philosophy part. Also, programming at heart and education. I love to dabble around with organizational ideas, what makes people work well together, stuff like that. Also, architectural style things, and together with Daniel, an old interest in security.
Yes, and as it turns out that we are both authors of the book Secure by Design, which you will probably learn a bit more about. And this is the most boring slide.
We might mention the ideas.
Yeah.
So we are from a company named Omega Point, which has got its headquarters in Stockholm, but we've got a few sites all over Scandinavia, I would say. I think we also actually have got a spot in Copenhagen as well.
That's right.
But our niche is kind of like in the intersection between application development and security. So cybersecurity, digitalization.
Yes. And of course, we do both Java, C#, everything you can possibly dream of. So, yeah. Anyhow.
Let's leave the most boring slide.
Yes, and jump to the conclusions in case you have to drop out, fall asleep, or I don't know.
Yeah. So, this might not make sense yet, but hopefully it will do in the end. So, our observation, a wisdom we took away from the Log4j incident, which we will cover, is that the application should be in charge of logging, not the attacker. Duh.
Kind of obvious, but yes, we'll see why that happened. We have a pattern called domain primitives that's actually pretty nice because that will help you reduce the attack vector to only valid values, and that can bring huge benefits to your software.
We're also going to draw some conclusions from the HTTP specification. Let's return to that specifics later, but we'll look at the HTTP.
And then there are some fundamental issues with not seeing logging as a separate subsystem. And not doing that means that you don't take care of the peculiarities that are in there, and then you are getting vulnerable to this type of exploit.
So our main observation is that had people been using these kinds of designs that we come to think of when looking at it, then this the exploit might have been this, but it wouldn't be in this large debacle where the entire world panicked. It's kind of like unnecessary. So let's see how we come to that conclusion.
Right. Okay, let's move on then. So what we will talk about today, of course, is we're going to quickly run through the anatomy of the actual attack, right? So you understand that one.
Just curious, anyone here has actually been looking into the attack a year ago or so? That's a little bit interesting.
Oh, are you security pros, by the way? No. Okay, good.
How many here self-identify as developers?
Thank you.
Okay, how many here self-identify as security experts?
Oh, we have one.
Yeah,
okay, one.
Great.
Good.
So we think there's really not so much of a distinction between the things. It's more that security is just a trait of development. So we try to see if we can bring a little bit of the design expertise that you all have and see that, hey, spin this, and you'll actually be security expert.
We will cover about 20%, maybe a little bit more, maybe 30% of OWASP.
20 to 30%.
Yes.
Yep.
Of course, secure by design, so you understand the concepts there, because those are going to be fantastic tools in order to fix this. And then there's some design patterns, right?
So the domain primitives will look at HTTP from design perspective, and then logging as a separate subsystem with an API of its own.
Right. Okay. So what did the report actually say, Dan?
So backtrack in time. Log4Shell hit like a Louisiana slugger. And if you read the CVE report, the second sentence in that says, an attacker who can control log messages or log message parameters can execute arbitrary code. That's bad. Loaded from LDAP servers, which is just a mechanism, when message lookup substitution, why does that happen, is enabled.
This is totally insane, to be honest.
I mean, it's a really heavy attack. It goes smack into most systems and says that, well, I can just upload some code somewhere, make the system download it, and execute it. It's kind of bad.
And the funny part here is that since it struck the entire internet, more or less, it was a fundamental flaw in how we think as developers.
On the other hand, it's also some kind of observation of the success of the Log4j framework. I mean, imagine how widespread it is. It's in the Java space, it's almost in every single application there is, in some way or another. A few that do alternative frameworks, but Log4j is really there.
Yeah. All right. So how did it happen? Okay.
Okay. So let's debrief it. Here's a very isolated example, and you might notice that this is Java because it's
capital S, therefore string.
Capital S
yeah.
And lowercase I.
Mm. Yeah.
So this is the innocent serve that in naive way say that, okay, I map up this index, and when I get a request, I receive a header API version. And what do I do with it?
I guess we just log it here, right? Saying received request for API version, I don't know, 1.0 or something.
Yeah. It's always a good idea to log your input data, isn't it?
Yeah. No. No.
Might? Okay, let's proceed.
So
this is the setup.
Yeah.
An innocent server just getting data, logging it. There might be some stuff before, some stuff after. This might happen down in some class, which is called via log, but in essence, this is kind of like the...
I mean, picture this being somewhere in the code flow, right? Somewhere in the code base.
So, Daniel, how could this possibly go wrong?
Well, what we would do is that we would rig an evil client and then an evil LDAP server.
Okay, I get that you got an evil client. I think we need to go back to the LDAP server in a little bit while, but could you explain what the evil client will do?
Okay. So basically, I mean, if you jump back here again, it says, string API version.
Okay.
But
so it's an input field.
Yes. And as a developer, I read this part and go, oh, API version. I know what to do.
I know API versions. That's like 1.0, 2.4.
Yeah. But as an attacker, I read string.
Well, I don't see. What's the difference?
Well, a string can contain anything, while an API version, I guess, is just, 2.0.1, stuff like that.
Okay. So a string, what kind of string could be that?
This string is $, curly brace, G in the I, colon, LDAP, colon, blah, blah, blah.
This is some kind of LDAP server and something.
You don't need to.
And this is, okay.
This is a very typical API version in some cases, right? Yeah. But the thing is that this $sign means something. In Bash and stuff like that, or PowerShell.
If I write echo, double quote, hello world, and double quote, you expected to say hello.
Yes.
Hello. Yes. Yes. And if I say echo double quote $, curly brace 4 plus 3 and curly brace then double quote, you expect it to say
7. Oh, what? Not
no,
dollar sign.
No, I
curly
expected
brace.
to say $, curly brace. No, that's because we know that the terminal bash or PowerShell has got evaluation, expression evaluation built into its language. It's a perfectly normal thing to have, and we are aware of it.
So your answer 7 is correct, but that's because we know that $ means something to resolve.
Now, let's proceed and see how this can be solved. So
this is what happens in the code, right? We replace API version by this string here. Okay, so we're good. But then we execute this, right?
And this is something that people seem not to be perfectly aware of, that log4j contains expression evaluation. So we've got a whole world of Java developers who use this framework, and I would say I claim 5 nines here.
Well,
5 nines, 99.999% of them are unaware that this framework they use contains an eval mechanism. That's Java developers for you.
so
A .NET developer would never make that mistake. Of course, you know perfectly well exactly what happens in the logging framework.
good.
Great.
So what happens here is that, log4j internally will react on this $. And what it does,
back up. And it does
it starts executing.
LDAP.
Yes.
Okay.
It starts resolving this, right? So what happens is basically we contact our evil LDAP server.
Which is loaded with
A file.
A file, which is a class file. This is the bytecode, which contains the bytecode of
Something to execute.
touch this file in the file system.
Yeah. And of course, what happens, you think? Well, this file gets pushed back to the vulnerable server, right? And it gets executed.
And now we are so relieved that it only touched a file in the file system and not did do anything else. Because that's what attackers do.
Honestly, if we reach this, it's game over. Because now they can execute anything in there and take control of everything. That's like, you've been pawned.
Yeah.
Yeah.
So this is the exploit in a nutshell.
Yes. So
let's look back at this sentence. It says an attacker who can control log messages or log message parameters can execute arbitrary code. An attacker who can control log messages. Who on earth thought it was a good design to let an attacker control the log? Is that a sensible design? I mean, who should be in control of the logging? The attacker, really?
it should be the application who controls what is logged and when it's logged, right?
I mean, that's sensible. We're not giving away control to like whoever happens to knock on the door on our system. That's kind of like a bad design. So there's some broken design here. So let's dig into and see what does this broken design really consist of.
So what we can really say that, the reason for why this actually happened probably is because, it was a less known feature in there, right? As developers, we did not see this as a separate subsystem that we need to map to, right? That we need to adapt to its whatever peculiarities it has.
Anyone here been using a database via SQL?
Yeah.
You know that if you pass in a parameter, you should be ensured that you escape the input data properly. Otherwise, it's named SQL injection. And we know this. We know the peculiarities of SQL. Likewise, we should know the peculiarities of the logging framework we use. And our observation is that we think that most developers do not take logging seriously.
So, basically, what can we do? Now when we understand this issue, and now you can sort of map this into your own daily work and say, hey, do I have a complete understanding of whatever library I'm interacting with? Hopefully you do. Well, OWASP, our guide, right? Our guiding star.
So OWASP has been publishing top 10 risk of vulnerabilities. I've got to speak.
And it's quite interesting that injection attacks has decreased over the years. It used to be number 1. It now is on the 3rd place. But at the same time, something called insecure design has popped up. And that means basically that if you have constructs in your code that may not seem, harmful, they can actually contain vulnerabilities that makes your code exploitable, like what we saw. And then we also have the vulnerable outdated components. And this is a little bit of a mind twist, right? How can we sort of link this one into Log4j or a logging framework?
So do I have control of what components we are using? Have we got control over that we know the peculiarities of them so that we are not surprised by this? Oops, didn't have that feature as well. And are we sure that we actually patch our third-party packages on a regular basis? Everyone here who patches their third-party dependencies on a daily basis, hands up. Okay.
Anyone who ever patched? No.
Weekly, monthly,
Yeah,
quarterly, yearly.
See, this is our problem, right?
When there is an article on Medium saying the entire world has crashed, do you update your dependencies then?
Yeah,
great.
See.
So, just a tip, there are a lot of excellent frameworks out there that can do this kind of scanning. When you build it, they build a bill of material, they cross-check against the CVA databases, and you'll get a ping. They're both commercial and open source.
I actually have to object here, because the vulnerability in itself wasn't really a vulnerability.
That's
it was
true.
a feature.
It was a feature with unintended.
Yeah. The only problem is that nobody knew about it or cared about it.
Which strengthens our thesis that developers do not care about their logging.
Mm-hmm. Okay.
Which is a pity.
Luckily, you're in good hands, my friends.
Because we know how to draw triangles. Daniel, this is ridiculous. What is on earth is this?
Well, this is the realm of bugs.
Okay.
All possible bugs.
Okay, of all possible in a system.
Yes.
Okay, so you got squares here. What's that?
That's just the wrong color of a button, I think.
Okay, so it should have been green, but it's blue.
Yeah.
Yeah, okay. This one?
I don't know. Maybe that was wrong version of a component.
Okay, and this was the sorting where suddenly got missed somewhere. Okay, but we've got some with triangles. What is this? Is that also a bug?
Yes, absolutely.
Okay.
The only difference there is we can have some sort of correlation with security.
Okay, so for example,
Log4j.
Oh, Log4j. Okay, so we're revealing information that should be confidential.
Yeah.
Okay.
Right. So
vulnerabilities sounds very scary, but they are just bugs. It's misbehaving code. So how do we fix or avoid misbehaving code?
We apply design patterns, right?
And one here who loves design. And then one here who loves to think about security all the time while coding. And one here who loves thinking about design all the time while coding.
Yeah.
At least a few more hands.
Yeah.
That's great.
So,
okay, this is a design you've been using, and it. Why does it only have a limited reach?
I mean, and this particular design pattern only covered some bugs, right?
Okay. So it could be dependency injection.
Oh, yeah, sure.
Okay, so dependency injection reduces the risk of a certain class of bugs. Not all bugs in the world, but a certain class of bugs. Fair enough. And here we've got other few designs that we can use, and they cover other things.
Yep.
So here we see that
we have green ones and red ones.
So why is this green one?
Well, because that particular design pattern covers a security problem.
Okay, so it's a design that was not originally conceived for security purposes, but it's got the neat side effect that it also reduces security problems.
Yeah.
Okay, and this is not green.
Because that one doesn't really cover any security problems. So it's not considered a secure by design pattern.
Okay, so this is something we'd like to turn around. When you are sitting coding, you probably use a lot of designs. If you think for it a while, you will probably realize that some of these of your favorite designs also have a neat side effect that they reduce the risk of some security-related bugs. If you take that and turn it around and say, that means I should use that design a little bit more often deliberately, then you are doing secure by design.
Well, of course, you can't draw that type of picture when writing a book, right? Because then they don't think you're a professional author.
Because
so you have to write something like this instead.
So what does it say?
A mindset and strategy for creating secure software by focusing on good design, right? I mean, it sounds better. Yeah.
That's at least 5 buzzwords in there.
Yeah.
So it's fully buzzword compliant.
So anyhow, now when we have this mindset, we say that, all right, maybe we can apply, certain designs that allows us to write code in a special way that prevents, the type of exploit that Log4j presented, right?
So what designs have we got?
Yes, we're going to bring in 4 things, actually. Domain primitives, it's a pretty cool pattern. We're going to look at how HTTP actually guides us here, which is kind of weird that you brought that in there. We have something called domain-oriented logging as an API. That's a pretty cool thing. And then we have something parentheses. Why do we have that?
Hexagonal security in depth, because it's not really a design pattern per se, but it's really an observation about how several different patterns interlock and support each other.
Yes. Okay, so let's dive into this because this is fun.
Okay, so domain primitives. Let's talk about code. Because at the end of the day, there will be code.
Okay, and this is C#. So, yes.
Because it says read only and not final.
Yeah. Anyhow, one of the cornerstones, I would say, in secure by design is the concept of a domain primitive, right?
Okay, domain primitive sounds like language primitive, but not language, but
yes.
domain instead.
It is almost similar in the sense that it's a concept that is so clear to the business domain that it needs no explanation.
For example, imagine that you were to design a language, a programming language that was niched to the hospitality domain, used in hotels, etc. So you would probably include a few primitives. Would you include Boolean? Perhaps. Would you include string? Perhaps. But what are the concepts that are so natural in that domain that they need no explanation?
Room number, right? Put it on my room is what you say, but then, what room number?
Yeah, so room number would be a language primitive in that language. It's a domain primitive. It's native to the domain. It needs no explanation. You walk into a hotel, everyone knows what a room number is.
And the interesting part is that if we apply certain properties to this, saying that this is an immutable object, it cannot change after creation, that's pretty nice. And we can say that if we also put in some intelligence into this object, we can say that it contains information or operations that allows us to, interact with this object. It becomes a little tiny, clever machine.
And one of the intelligent pieces that we insist on is that it should be able to do its own validation of itself. So, in this case, if you try to create a room number of room number 205, it will just go okay. But if you try to make room number minus 101,
that would probably not be okay, right? Because what kind of number is that? What kind of room number is that?
It will probably say, if I go to the bar and then I say, put it on my room number, minus 101, I hope that it's deducting it from the tab.
Yeah.
Or something else weird.
Yeah. Anyhow, what's so interesting about this pattern, because this is actually a session in itself that we can dive into, is this fact, right? If we have user input, and now you took minus 101, which you obviously said, well, that's not something that can be accepted. It's going to be rejected upon creation, which means that it won't actually reach the sort of hospitality application here, right?
Note here that user input might be a web page. It might be a batch job, which is a batch file which you have imported from some partner or some other. The point here is that -101 in this kind is just a string. It's just a string or an integer. It doesn't carry that inert meaning yet. And that is what we're trying to do here.
And the interesting part from a security perspective is that we have suddenly reduced the attack vectors to not being any integer possible in compute space, to only the valid room numbers. And that's a huge difference.
Okay. Theoretically now, could there be an attack vector, attack string, or an attack number that would fulfill this requirement and still make some harm on the inside?
Yeah. If you remember that old, legacy system where room 42 really means janitor's office, then that can be injected, right?
Yeah. So we are not eliminating any possible attack vector, but we are really scoping in that there's only a small window apart from all the integers, all the strings.
And think about it as a string. A string can be anything to only be the API version. Now you sort of get it.
So
yeah. Okay. So if we look at this in code-wise, how would that look then?
Okay, apart from that we need to apologize for like mangling Java-ish code with C#-ish code together, you have to like squint a little bit to see it.
Then these are very intelligent people. They did not even have this exploit. So
yeah. And I see a compiler, the API version.
Yes.
Whatever. So we introduce a class API version that kind of wants to capture the essence of being a proper API version number. And then we say that to do that, we have some kind of wrapping, not unboxing, but wrapping video here, where you are giving an API version in form of a string, and we do some kind of validation on it. It matches some kind of pattern. The matches pattern somewhere in the validation framework somewhere, without getting into details. And if it succeeds, it wraps up this and packages as a read-only property inside the API version class. So if you get an API version object, you can be sure that what's inside there is actually, it's sealed and stamped that this has gone through the proper validation.
Do you actually notice that we're still having a problem here? We actually log user input, right? See there on that line, log4j info. But the fact that we changed the yes, there we go. We changed it. We put it into the API version object. We sort of shrunk the possible values that it gets out of there, right? Okay. So that's still okay, even though it's kind of bad still, but we're moving in the right direction.
So at least we have shrunk the attack surface a lot. But we have a problem. We need to point out a problem. What happens if we receive this attack string? How will the system react?
Dollar, all that stuff?
Yeah.
Okay. Yeah, then we probably explode because matches pattern throws an exception, I guess.
Yeah, some kind of exception, which means that the API version API row will throw an exception, and what will the user receive?
Error 500.
Which error? 500 we messed up.
Yeah, not good.
In terms of error.
Yeah.
And that is not good.
Let's get back to this, though.
So we'll make a side note on that one.
Yes. Okay.
But perhaps we should dive into the HTTP stuff.
Yes, but I do want to take this takeaway first, though. And that's actually, if we sort of do this, remember it now, we reduce attack surface, and the attack vector becomes smaller, right? And that's a huge benefit for us. Okay.
On a side note, of course, domain primitives has loads of other benefits.
Yeah.
It's really nice. It builds a language on which the rest of the application can stand. It makes it more expressive. It's make it easier to unit test, yada, 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 yada. But we don't care about that right now because we care about security.
Yes. So the next question is that would this have been enough? Well, the problem is with those 500s, right? that would have screwed up the entire application and the and also, if we are fair, think of an application that would accept, I guess, some sort of free input text field saying, I want to ask about this code, or what does this LDAP string do, right? So you can get past the domain primitive saying, oh, the only thing we could have done is to say we accept only up to, I don't know, 200 characters or something like that, right? So we could actually get past our domain primitives.
If our input would be a forum where we discuss security-related, software-related stuff, then we have to let these data through.
So basically, only relying on domain primitives gives us a perimeter-based security, right? Sort of, if you get past the fence or the wall, then you are home free. But NIST, you guys know about NIST, right? The National Institute of Standards and Technology. Isn't that what NIST stands for in the US? Like they do all these recommendations for how you should do stuff. Sort of like OWASP on steroids. But what they say is basically that you should have a layered security architecture where you basically apply multiple patterns in order to get defense in depth, or what we call it, security in depth.
Yeah. So what we want to make is to, if you get over that parameter, we want to make it hard to walk inside the inside area. Yes. So to do that, we try to apply a lot of different patterns.
And it almost looked like that was some sort of layered cake, right? That you have an N-tier security stuff. But what you really should have is more of a hexagonal structure where you would apply patterns that help each other, like the domain primitives should go into domain-oriented logging and so on, right? So they use each other and make it very hard to sort of reach the target inside of your application. So yes.
So we have two more patterns we want to cover.
Mm-hmm.
So let's get going.
This is the weirdest one. Yeah.
What does HTTP say about logging? Have you read the HTTP specification? Of course you have. Yes. What does it say about logging?
Nothing.
Nothing at all.
Yeah.
So if we read it a little bit more carefully, we can still deduce a few things that are related to logging. So let's dig into it.
Okay.
So HTTP talks about request response. You all know it. You send a request header with get, put, post, head, whatever as a verb. The server do something. The client might be a browser, single page application, might be a batch job that executes one call per line in the batch file. Fair enough. The server tries to fulfill the request and then return a status code. 200 for OK. A few versions of 200, 201, 202, etc., whatever. It might return 400, bed request, forbidden, didn't find the entity, or it might say that, well, 503, unavailable, or 500, I messed up.
And if you're really, really unlucky, they have made a design where they say 200 OK and then a payload error. Yeah, do not want to interact with those guys, but yeah.
If you're really lucky, you get a 418 back.
Yeah.
Then at least you know you've got an API developer on the other side with a sense of humor.
Yeah.
So when the server, now the HTTP specification distinguishes two very distinct things. When the server errs, it says that the server error 5xx responses indicate cases in which the server is aware that it has erred. Not that it happens to get an exception, but it was actually its own fault. So that's what 500 is for.
So Dan, if the server has erred, I love the word erred, by the way, sorry. Who should log?
The client?
No.
No, that's of course. If I mess up on the server side, it makes sense that I do the logging. I have messed up. Someone need to get out of this. We need to do it for some kind of operational recovery, for forensic. That's a fashionable name for debugging after the fact. We even might log data or context. You might create a ticket, a lot of stuff. Will the client log such a response?
I guess what the client should do is to log its input it sent, right? Should the server log the input?
Probably not. It will probably do something around here, but if it logs the data input that made it crash, it need to be very careful about doing that.
Yeah.
Perhaps you should log base 64 encoded version of it, or a hash code, or stuff it in some database where no one will touch it because you need biohazard gloves. But in general, but at least it makes sense that the server will log when it crashes itself.
But that was the case when the server had error, and that was not the case for Log4j though.
Was it the server that faulted on the Log4j attack?
No.
Not really.
So
let's look at the other one.
Yeah.
What happens when the client errs?
Well, in this case, the server shouldn't do anything, right?
Probably not. I mean, 400, for example, bad request is reserved for the situation when the server has done everything it should, but it cannot do something sensible because of the stuff that the client sent. So if we look at what we probably should send, if someone sent XAPI version 4.2.6,
that would be fine, I guess.
No, it wouldn't, because
Really?
in our specific server, we only accept major, minor. That's a peculiarity of this particular system that the client should be aware of. So this is a client fault. So I will return 400 bad requests that XAPI version does not fit the format digit point digit.
Okay.
Because that's my domain. I am in charge.
So if you look at it from a log perspective, I guess, the client should be responsible for logging whatever input it sent in that case. And
it might log it, or it might turn it back to the user interface, or it might do something sensible. Should the server log?
It's so easy to say no, but you all know that there are some political reasons, right?
Most probably not, but we can of course come up with some kind of political reason why we should do it. But we should definitely not do it like just by doing it for big debugging or whatever.
Yeah. So if we would send the LDAP, the Log4j attack vector, that means the client erred.
So it doesn't, from HTTP perspective, it doesn't even make sense that the server would put this in a log at all. It's not its fault. It has done its job. It has reflected back, said that this is a bad input. The client knows which input it just sent, so there's no need for reflecting it back. On the server side, I might log that I have returned a 400 bad request as part of my HTTP log. But logging all the details thereof, not really any compelling need for it.
So basically, our takeaway
your mileage might vary. Of course, in your particular situation, if you find a really compelling reason to do so, well, of course you should. But then take the precautions that are appropriate.
So basically, we have tricked the server into logging something it shouldn't. I think that's the gist of this takeaway, right? So if we revise the domain primitives again.
Okay, remember that the domain primitive we introduced caused us to make a 500 internal server error because we just crashed. Of course, that's a bad idea. So we need to revise it. So how can we get out of that?
Well, we would actually call the write is valid method. That's a small I, or lowercase I, so should be the capital one. Sorry about that.
But that is Java and Java C#, and the runtimes will just magically make them match.
That's a glue.
Some way.
Yeah. Anyhow, what you should do is basically allow you as a client to this domain primitive check the validation and go, all right, I have this input, check it, it runs that, and if it is okay, we will proceed. Otherwise, we will respond then with a 400, right?
Okay, so now we're at least dug us out of that particular pit hole.
The next pattern to have a look at is, of course, something called domain-oriented logging API.
So let's take a separate look at logging. If we look at the system from a hexagonal architecture perspective, not as a layered cake, we can see that we've got the client that calls the application, which is a kind of a context jump from one context to another. We have that the application might contact the database, which is also context jump. What do we need to do when we switch contexts?
We need to map to that particular context, right? We need to adhere to whatever peculiarities it has.
For example, the earlier mentioned SQL databases, where we need to do some kind of encoding. It might be that we're reflecting things back to the client, in which case we need to, if the client is a web browser, we need to encode our output for that particular version so that script does not get rendered.
Yeah, so we don't have an
will get rendered, will not get executed.
Yeah.
So putting logging into the same context, this is also a separate part of the system.
And therefore, if we ever reach the logger, we need to encode it properly. We need to adapt to whatever it needs to get done with the data, right?
And some inspiration for this design idea is if you look at the 12-factor manifesto, familiar since before? Otherwise, I encourage you to check it out. It says 12-factor, 12factor.net. It's 12 pieces of advice on how to survive in a cloud environment as an architect. And one of the pieces of advice is to treat backing services, like the database or the logging system, as attached resources. That is, as a separate subsystem. And we think it's a very solid piece of advice because it encourages you to think about the logging as a subsystem in the same way as the database is a subsystem. And take it seriously.
So, if we have a look at what we had in the beginning, we had some sort of bare metal logging, right?
Yeah, Log4J, and we just write onto it. And we are in charge of composing the string in some.
The problem with this is that we have not, I mean, we only see Log4j as like a standard output stream, right? Writing strictly, it should write whatever we send to it. We don't expect it to evaluate anything doing this way. But if we would introduce a concept similar to the domain primitives, if we would wrap the logger framework with an API that speaks domainish, makes sense? Saying that, okay, so in my domain, it makes sense to say, I want to log a room number, or I want to log a reservation, and things like that. Then you would say, as a developer, unfortunately, I can't log just anything. It needs to be something that's part of the API of that service.
So you would need to express yourself in the language of this API.
Yes. And
for example, saying log a reservation or reservation cancelled or guest checkout or something like that.
And as developers, we would say, hey, I really need to log this API version. And you as a team would then go, does it really make sense to log an API version in this particular context? And if it does, you would, of course, add it to your API of doing this. It makes perfect sense. Because on the other side of this API, you can actually do an educated separation of data.
For example, what purposes do you log for? Of course, you need to log some kind of operational tick, but you would also like to log metrics about how does the system perform, or some kind of audit data for GDP or some business intelligence or operational failures.
And you can actually have different life cycle management of this data, right? You can say audit data needs to be present for 15 years after the system has terminated, whereas metrics data, well, I don't know, after 2 days you don't care. So you can have very different solutions for storing your log data. And here's the neat trick. You can make sure that it's only the application that can write to these logs, whereas you as humans are able to read the logs, right? You can't write to them, which means it's very nice from a, I guess, audit perspective. You can have it can be GDPR compliant very easily, right? Saying I can access this, traceability of there. And you can make sure that it's only the application that can actually modify data, but never read it.
So, taking this back to code,
yes,
how would that look like?
It's
so
quite
instead
simple.
of having this naked bare metal logger, we would have...
We would actually wrap that into something we have called now the Hello World domain, Hello World logger, right? And the interface would look something like this, I guess. We have, the log API request, and we have log say hello, and things like that. That makes sense in this particular context, I guess.
We admit it's getting a little bit hard here to make up real sensible events in the Hello World domain, but you get the idea, huh?
But now, the interesting part is that if we, first of all, this object fits in here, right? So it's like a piece of a puzzle goes in there. And on the other side, we choose to extract certain parts of it. And if we have now magically passed our domain primitives, on the other side, we make sure that, well, here we do proper encoding for that system and this system and so on, right? Because that's what we do in one place, in this service. So, the takeaway, if we treat it as a separate subsystem with its own API, then we can actually also take care of all the peculiarities and make sure that whatever data we send there is going to adapt to whatever requirement it has.
And this is where we feel a little bit, at least the Java community has failed. Basically only treating the log as some kind of dump where you do catch exception, throw it on the log, stack trace on the log, without much consideration of what is the purpose of doing this. And we think that if you talk about a DevOps culture, this is really one of the sign of nobleness. If you take your logging and it actually looks at how does this system behave during runtime, so that the operation people will be able to see what is happening by looking at the log, that each log has got some kind of purpose, then you're taking a huge step forward. And that is what we put into the phrase of treating treat it as a separate subsystem of its own.
Right. And now the conclusions makes perfect sense, right? The application should be in control of the logging, not the attacker, right?
Yeah. Domain primitives enforce early validation, thus reducing attack surface to only the semantically valid data.
And for some reason, the attacker was able to trick the server into logging things. That's the reason why that actually was exploitable, because the developers did not care about the peculiarities in the logging system.
Yeah. And we can get some guiding from the HTTP specification that, well, it wasn't even sensible to make logging on the server side to start with, because of how the HTTP specification talks about the interaction between client and server, the 400, 500 faults.
Right, and the entire debacle could have been avoided if we had used a secure by design mindset, right?
The vulnerability would still be there. It would still be impossible to be exploited, but it would just be a blip on the radar and some minor notice somewhere. It wouldn't have been this kind of like massive debacle.
Right, I think we have like 1 minute for Q&A. So any questions?
Or any comments on how you think this align with your experience?
I think it's us between the bear and yeah.
We'll hang around. Come and have a chat with us. Thanks a lot for your attention.
Thank you.